Welcome to one more session of numerical aptitude for competitive examination. Now here we propose to give questions which ideally should be solved in 3 to 5 seconds. And we will show you how you can solve in 3 to 5 seconds. Now let's take the first question. In a test with 26 MCQ multiple choice questions, 5 points are awarded. Sorry, it should be 8 points. 8 points are awarded for each right answer and 5 points are deducted for each wrong answer. Plus 8 points for right answer and minus 5 points for wrong answer. How many answers were correct if a boy scored 0, although he attempted all the questions? Now apparently, this does not look like a question on mixture, but it is a question in mixture and alligation. In fact, what we are mixing the right answers and the wrong answers in a certain ratio to get 0. A right answer, which is 8 point each answer, and wrong answer, which is minus 5 point each answer. The right and wrong answers are to be mixed in a certain ratio so that the net rating is 0. So actually we are mixing right answers and wrong answers. The worth of right answers being plus 8 and wrong answers minus 5, and the mean value, the net average, should be 0. So whenever we have this kind of mixing, we can always, this should be 8 points. Sorry, this should be 8 points, not 5 points. So we can use a cross difference method. For right answers, the higher value plus 8. For wrong answers, the lower value minus 5, and the mean required is 0. Ultimately, it is 0. Now, cross difference. This is how we cross difference. 8 and 0 difference is 8. And cross difference minus 5 and 0, the difference is 5. So, ultimately, ratio we're getting 5:8. But 5 plus 8 will make 13. And you have 26 questions. So, you double it. Instead of 5:8, you write 10:16. Now the total is 26. And 10 questions were right and 16 questions were wrong. So cross difference method makes solution easy and simple and time saving. Make use of cross difference method whenever you have mixing of two things. Next, a certain quantity of milk with 16 liters of water. Water is 16 liter, milk quantity unknown, and there is a mixture of an unknown quantity of milk with 16 liters of water. It is worth 90 paise per liter. If pure milk is worth rupees 1.08 per liter, how much milk is there in the mixture? This is a question on mixture or alligation. We are mixing water and pure milk in a certain ratio to get dilute milk. So let's see how it works. Only water 0, pure milk cost is rupees 1.08, or we are converting it to paise 108. And the mean value of water and milk mixed up, the mean value is 90 per liter. So cross difference 0 and 90, difference 90, 108 and 90, difference 18. And so we get the ratio 18:90 or 1:5. Now 1:5, but this we want 16. This is given 16 liter water. So if you want this 16, then this should be 16 to 5, 80. The ratio remains 1:5, but to make this 16, we have to multiply 1 into 16 and 5 into 16. We get 16:80. This is water and this is milk. So 80 liters of milk was there in the mixture. Cross difference method simplifies all questions on alligations. It makes them very easy and you can solve it in a very short time. A certain sum of money can pay A for 15 days, or it's not and, it's or. It's important to note that. The same sum of money can pay B for 10 days. How many days it will suffice if A and B work together? Now, to avoid fractions, we take the LCM of 15 and 10, which is 30, and we suppose the amount to be rupees 30y or rupees 30x. 30 is the LCM of 10 and 15, and we have taken the LCM in order to avoid fractions. So 30y is the rupees we are assuming. If 30y can pay A for 15 days, then his rate is 2y rupees per day. And if 30y can pay B for 10 days, then his rate is 3y rupees per day. So when both of them work, you will have to pay 2 plus 3 or 5y per day. And 5y per day if you pay, and total amount is 30y, then it will last for just 6 days. 30 divided by 5, 6 days. So we take the LCM in order to avoid fractions. Next, in how many ways can coins of rupee 1 and rupees 2 be mixed to get a total value of 100? In how many ways? So there will be infinite number of ways. Only rupee 1 you can give 100 coins. Only rupees 2 you can give 50 coins of rupees 2. So there will be infinite ways. So let's see. First, let us take the higher value, 2 rupee coin. Now 2 rupee coin, you may give 0 coin. That means you may choose not to give 2 rupee coins. You may give 1 coin. You may give 2 coins. You may give 3 coins. You may give 4 coins. Like that, ultimately, you can give 48, 49 or 50 coins. The number of coins of rupees 2. Then, if you give 0 coin, it is 0. If you give 1 2 rupee coin, it's 2 rupees. If you give 2 coins, it's 4 rupees. If you give 3 coins, it's 6 rupees. If you give 4 coins, it's 8 rupees and so on. And whatever is the remaining, you can pay in using rupee 1. Whatever money you have paid, whether it is 2 rupees or 4 rupees or 6 rupees, 8, 10, 12, 14, any amount that you have paid using 2 rupees coin, the remaining amount can be paid using 1 rupee coin. So the total number of ways, you can take 0, 2 rupee coin and the remaining 1 rupee coin. You can take 1 2 rupee coin and the remaining 1 rupee coin. So how many ways? 0 to 50, the total number of ways is 51. There are 51 in which, the 51 ways. 51 ways in which you can combine the two types of coin to make rupees 100. A milkman has 2 containers containing milk and water in the ratio 1:4 and 1:2. He has 2 containers. The first container has milk water 1:4 and the second container milk water 1:2. He mixes the two in the ratio 3:2. The first container he takes 3 parts and the second container he takes 2 parts. If the profit earned by selling the diluted milk from the first container was 20%, what will be the profit or loss if it sells the final mixture at the same rate? At the same rate. It should be at the rate or at the same rate. So you are having 2 containers. One is 1:4 and here you have got 1:2. You mix them. How do you mix them? 3 parts from here and 2 parts from here and sell them at the same rate at which you are selling the first one. And here if you got 20% profit, what would you get here? Now, it should be at the same rate or at that rate. The word is missing. At first, make the total in each ratio equal. Whenever you have to mix, like 2 parts from this one, 4 parts from this one, 5 parts from that one, the total should be equal. So we can't take 1:4 and 1:2 as such, because here the total would be 5, here the total would be 3. So you have to make them equal. 5 and 3 LCM is 15, so let's make 50. So multiply by 3. 3 is to 12, and if you multiply by 5, 5 is to 10. Here also the total is 15. Here also the total is 15. Now you can take 3 parts from here and 2 parts from here. So if you take 3 parts from here, it will be 3 into 3, 9, and 12 into 3, 36. And if you take 2 parts from here, it is 5 into 2, 10, and 10 into 2, 20. So this ratio multiplied by 3, both the terms gave 9, 36, and this ratio, both the terms, you multiply by 2 parts, they give you 10, 20. Now add the milk. The first one is milk. Add the milk and water separately. The milk, if you add 9 plus 10, 19, and the water, if you add 36 plus 20, 56, making total 75. And now we have to compare with the first variety, which was 1:4. But again, 1:4 is to be written as 15:60 because the total has to be 75. Whenever you are comparing two things, the total should be equal. So we write 1:4, which was the first container milk. We write 1:4 as 15:60, so that the total is 75 in both the cases. And in both the cases, the selling price is same. Quantity is same, selling price is same. Now, since he sells at the same price, the rate is same and both are 75 total, so both he will get the same price. Quantity is inversely proportional to price. The total price is fixed, so quantity will be inversely proportional to price. Now we are considering for price, we will consider only milk. Water we can forget. We will consider only milk for when we calculate the cost. So 19:15, inverse proportion, that's 120 is to X%, where X% is a percentage of cost price he gets on selling the mixture. So 19:15 is 120 is to X. Milk alone matters, not water. That's why we are taking only milk, not water. This we needed only to make the ratio equal. So milk is to water, water, but that was for making the total equal. But here milk alone matters. Water does not matter. So 19:15, inverse ratio, 120% is to X%, and you get X as 94.73%. Now whatever you get above 100 is profit. Whatever you get below 100 is loss. So since it is below 100, it is loss. 100 minus 94.73, so it would be 5.27% loss. Loss because it is below 100. So if you subtract from 100, you get 5.27% loss. So whenever you are taking, say, 3 parts from one mixture, 2 parts from one mixture, or when you are comparing them, the total should be made equal. The total should be made equal. Here we made total 15 and total 15. Here we made the total 75, total 75. The total should be equal. Otherwise, you cannot compare. Comparison is not possible if the total is not equal. Thank you. That was our session on how to solve numericals quickly and easily. We will be coming back with more such interesting videos. So look out for our channel. Subscribe and like it. Thank you and goodbye.